Hi, today we're going to be making a lithium iron phosphate battery pack by connecting lithium iron phosphate cells in series with one another. In this example, I'll be making a 9-volt nominal pack by connecting 3 lithium iron phosphate cells in series. You want to start with a clean workspace on an insulated surface. Any wooden workbench will do just fine, or a laminate desk. Here we have a laminated table covered with a non-slip rubber pad. This is just to keep things from rolling around, and the rubber is also an insulator, which is very good. It's also a good idea to wear a pair of insulating gloves. These latex rubber gloves will work just fine. This will protect you from getting any kind of electrical shocks while you're working with the batteries. The only tool you'll really need to construct the pack is this Phillips head screwdriver. But in this example, we'll also be using a few other things. We have our voltmeter that we'll use to measure the voltages of the cells. Our Noalox antioxidant compound. This is to rub into the joints, the interconnections between cells. It keeps them from oxidizing, rusting, and getting any contaminants that will deteriorate the performance of your battery pack. And we also have this, a rag. This is to apply the joint compound. So let's get started. We'll start with our lithium iron phosphate cells. They should come in a box like this. They're available at KennedyAlternativeEnergy.com. Each one has a screw terminal on both ends. We'll start by removing the screw terminals. Okay. Now we also have these. This is the copper intercell connector. You can also get these at KennedyAlternativeEnergy.com. They're designed specifically for these lithium iron phosphate cells. They have 6mm holes to fit these screws, and they have 40mm spacing. This allows for 2mm of airspace between the cells to keep the heat down and to keep everything operating smoothly. The first thing you want to do is squeeze a little bit of your Noalox antioxidant compound onto a cloth or a rag, just like this. You can blot the compound together and rub it into your copper connector. Get it into all the pores and pits of the copper. And this will keep it from oxidizing and keep your pack working well for years to come. You may also want to rub a little bit onto the ends of the connectors of the cells and onto the screw terminals themselves. Take note of which end you're using. You have the positive end of the battery, the negative end. We'll start with the positive side and we'll connect our first copper connector. Use our screwdriver, make the connection. Just want to hand tighten these. You don't want to screw them too tight. You might damage the cells. Now that we have our copper connection on our positive side, to connect the cells in series, we will be connecting from positive to negative. So we'll connect to the negative terminal of the second cell. And there you have it. These cells are now in series. You can see, if we use our voltmeter, the voltage of each individual cell should be around 3.3 volts resting voltage. 3.33, 3.330. When we connect the cells in series, you add the voltages of each cell. So this pack of 2 should have a resting voltage of about 6.66. And let's check. There it is, 6.66 volts. We'll finish the 9-volt pack by adding one more cell. We can remove our connector. Rub in your NOALOX compound. And make the connection. Make sure you're connecting from positive to negative or negative to positive, as the case may be. Now you may be noticing that I'm using this short little stubby screwdriver here. It's recommended to use a tool like this rather than a longer screwdriver such as this. And this is to avoid any type of accidents. You can be working on the cells and easily drop this and short out the terminals of two cells. Easily can make a mistake that will damage the cells and possibly cause an injury. So it's better to work with something like this. You can see here we've gone positive to negative, positive to negative, negative to positive. And there you have it. 9-volt pack is completed. 3 cells in series. We can check the voltage of the pack with our voltmeter. And you can see 9.98 volts. It's a little bit larger than 9 volts because each cell, the nominal voltage is 3.0 volts, but the actual resting voltage is closer to 3.3 volts. And we're done.